Okay, two equations go along with dilution problems. They're listed on the front of this review, but I'm just going to list them here. And that is that MCVC equals MDVD, and which is molarity of the concentrated solution times the volume of the concentrated is equal to the molarity of the diluted solution times the volume of the diluted solution. And then you have the volume of the diluted solution is equal to the volume of the concentrated plus the volume of the water that was used to dilute the solution. Because every diluted solution is simply a concentrated solution with water added to it. Okay? If you add 1 pack of Kool-Aid to a gallon of water to dilute it, you add another gallon. So, let's start with a basic dilution problem. 50 milliliters of a 0.357 molarity KCl solution is diluted to 250 milliliters with water. What is the molar concentration of the final solution? Step 1, read the problem, circle what they give you, underline what they want. The most important thing is that you are careful about which volumes go with which molarities, which is why when I circle them, I draw the arrow. So 50 milliliters of this solution. They go together. If they go together, they go on the same side of the equation. Okay? So, molarity in volume 1. My molarity is 0.357 molarity. My volume is 50 milliliters, which turns into 0.05 liters. The molarity of the final solution is what I'm solving for, and the volume of my final solution is 250 milliliters, which converts to 0.25 liters. On your reference tables, the formula M1V1 equals M2V2 is on your reference tables. And the reason that they use 1 and 2 instead of concentrated and diluted like we do, or acid and base like we do in titration, is because it's the same equation for both situations, and they just assume put 1 and 2, okay? But the important part is that you realize which volume goes with which molarity and keep them on the same side of the equation. So, I have MV equals MB. This goes on the left side, this goes on the right side. Doesn't matter if you call it concentrated or diluted or 1 and 2. Just make sure that they are, the volumes and molarities are on the right side with the right partner, okay? Molarity 0.357, excuse me. Volume 0.05. I am solving for this molarity, and my volume is 0.25. I like to do one step at a time, that way you make fewer mistakes. So my first step is going to be to multiply the left side together. And I get 0.01785 equals M.25. My last step in solving for the molarity is to divide both sides by 0.25. And my final molarity would be 0.07. Now let's try a molarity problem, or excuse me, a dilution problem, where we have to use that volume of water, okay? This problem says what volume of water would be added to, it's looking for volume of water, would be added to 10.5 milliliters of this solution of sodium borate in order to get a 0.03 molar solution. This is a two-step problem. I have my first volume, which is 10.5 milliliters, which is equal to 0.0105 liters. I have my original molarity, which is 0.0813. I need to find my final volume so that I can use it to find the volume of water. I need two volumes to find the volume of water. I can't just find the volume of water, so I have to find this second volume first. So my final molarity is 0.03 molar. Again, left, right, MB equals MB, 0.0105, 0.0813, I do one step at a time so that I make fewer mistakes, so I'm going to multiply these together first. And I get a nice long number, which you won't have to write out because you can just simply press divide in your calculator. Then I divide both sides by 0.03. And my final volume is going to be 0.029 liters. Now I can find the volume of water. My volume of my diluted, which is also the final volume, is equal to the volume of the concentrated plus the volume of water. This goes here, 0.029 liters is equal to, go back to your original problem, I started with 0.0105 plus a volume of water. Now, I just subtract. And my volume of water, which is the answer, is 0.029 0.185 liters, or 18.5 milliliters.